Hi, my name is Mirko Lenz, and together with my colleagues Lukas Malburg and Ralf Bergmann, I developed a new case-based reasoning toolkit for Python called CBRkit. So in this talk, I would first like to provide some introduction and motivation why this is even necessary, show you the framework, provide insights into our user study, and conclude with an outlook to future work. So let's start. Why is it even necessary to think about a new case-based reasoning library for Python? So when thinking about Python, you may be considering machine learning. So some could argue that we have a scenario where we have case-based reasoning going against machine learning, but we think it should be, or it would be even better to integrate both. So one way would be integrating machine learning approaches in CBR. So CBR typically has knowledge-intensive representations such as attribute value representations. And machine learning could be used here to automatically learn similarities for individual attributes. We could also use it in a MACFAG pipeline. So many are called, but few are chosen, where a complex similarity measure in the FAG phase is approximated using in the MAC phase. And this could be done using a classifier that is trained to estimate and predict the similarity values that occur in the complex similarity computation. Lastly, it would also be sensible to use embeddings based on machine learning in textual CBR, for instance, for strings and texts. And then the other way around is also possible. So we found that analogy-based reasoning currently is not used that often. For instance, in scikit-learn, we only have KNN available as an analogy-based reasoning approach. And the adaptation phase of the CBR could also be sensible for machine learning. So imagine you have a classifier that predicts something, and then we could use adaptation, for instance, via rules, to provide even better predictions. When thinking about large language models, we could use a CBR pipeline to do retrieval augmented generation, where the knowledge-intensive similarity measures from CBR are used to have better and sometimes even structured retrieval pipelines. And lastly, in the domain of XAI, black box models could be explained using CBR. When designing our CBRkit library, we first began with a requirement analysis. So we sat together, had brainstorm meetings, and thought about what a CBR framework should offer, and also drew experience from prior developments. So first of all, a CBR framework should follow software engineering best practices, meaning that it should have good documentation, proper testing support, type annotations, or even strongly typed. So everything that has to do with software as an engineering. Then it should also provide interoperability. For instance, you should be able to use it via a REST API. You should be able to use it by importing it into other Python modules, maybe provide a command line interface as well. So just different ways of using it. And then we have thought about more CBR-related things. So one thing here is high-level abstractions. We think that a CBR software should provide a pre-manufactured similarity functions, retrieval pipelines, and so on that you can easily use, like going to a clothing store and just picking some t-shirt that you like. At the same time, it should also be possible to do low-level customization, like going to a tailor and having a suit tailor-made for you. So in our CBR framework, that means, for instance, you have an attribute where the existing similarity metrics are not the perfect match, then you develop a custom one. But you should at the same time be able to use the provided similarity measures as well. So low-level customization and high-level abstraction should work together. And lastly, we have integration with machine learning frameworks, meaning that the library should be compatible with, for instance, NumPy arrays or pandas data frames and so on, and make it also easy to integrate, for instance, a custom PyTorch classifier. We then continued and searched for existing Python-based CBR frameworks and found a few of them, but none of them had or ticked all the boxes for the requirement we just formulated. For instance, when looking at Cloud CBR, a CBR framework specifically designed for the cloud as a microservice-based architecture, we see that it provides good abstractions, but for instance, it cannot be used directly, or it is not meant to be used as a Python module, and it's not optimized for that. And also, it does not use type annotations extensively. Now, we see that there are also two other existing libraries that also don't tick every box, and even CBRkit does not have everything perfect right now, because we see that it does not provide all abstractions we need. For instance, the adaptation phase is currently not supported and needs to be implemented manually. So we focused on Retrieval for the first public version, but we are working on that. So to sum it up, there is no perfect CBR framework as of right now. Now, continuing with the framework itself, you can find it here on GitHub. And I thought it may be best to first provide some overview and then show you some examples of what actual code looks like. So CBRkit uses a compositional and functional approach, meaning you can take existing similarity functions or retrieval pipelines and compose them. You will see what that means later on. And functional, meaning that we don't rely much on classes, but instead have functions that can also be used as arguments to other functions as well. We provide abstractions for retrieval pipelines and importing cases, making it easy to perform retrieval. As I said, the other stages are in development. We offer first-class support for pandas data frames, basic embeddings are built in, and even sentence transformers, and it's also easy to integrate custom classifiers. You can use it directly via a REST server, a command line interface, or import it into existing Python code. And as I said, it's possible to combine the built-in similarity measures with fully custom ones. Some notes regarding the engineering. CBRkit is fully typed, so every function has type annotations. We have end-to-end tests and also individual tests for the functions and documentation for the entire code base that is then auto-generated to a web page. The code is available under the MIT license with releases published to PyPy, meaning you can just do pip install CBRkit to get started. The command line interface can easily be used via Docker as well, so you can use it on any system, even if Python is not installed. And the continuous integration is powered by Nix and GitHub Actions, making it reproducible. Now, going through the examples. First, we will start with a relatively simple one. We see here that in the first line, we just import CBRkit as we do pandas as well. Then we read some casebase. Here it is stored as a CSV file. And then we import this data frame, because in CBRkit, a casebase is essentially a dictionary with a key pointing to some value. This value may have an arbitrary type, and in this case, it's basically a pandas series. So the query needs to have the same type as the cases in the casebase, so we define it as a pandas series with certain attributes here. And then we design a similarity function we want to use here. Given that we have a CSV, we can use the attribute value helper, which makes it easier to do to define similarity measures on tabular data. And we could, for instance, just say, okay, we have here now 2 attributes in our query. And for each of those, we define some similarity functions and say, okay, the paint color should be equal. So the car has to be red. And for the year, we use some threshold numerical similarity. You will see the definition later on. The retriever is then built. So we say we want to use our similarity function here and retrieve at most 10 cases. And then finally, we apply the retriever. So we give it the case-based retriever, the query, and the retriever, and then get a result containing the similarities and also the resulting ranking. And we even get local similarity values for the individual attributes in case we need them. Now you see that here the similarity functions are called. So you may think, okay, now we have some value here, but it's not computed across the entire case base. But we use a special pattern in CBRkit. So here on the next slide, you can see that, for instance, the threshold similarity is customizable. So we have some parameter here, which is the threshold. And then inside the function, we define a new, we call it wrapped function or nested function that does the actual similarity computation. And each similarity function in CBRkit follows the same signature. You have X and Y of the same type, returning some float. So we see here that we return a float, and the actual call to a threshold similarity just returns this function. So if we go back one slide, we see that if we call this statement here, we basically get a function that is then passed to this attribute value helper. Okay, this is why this is called. Now, going to a more complex example, we again import CBRkit and pandas, load our case base, and now we define a more complex query. We see that we also have nested attributes now. This model, for instance, just is another object that contains certain attributes. Now we want to do a MAC-FAC retrieval here, so a pre-filter in the first stage and then a more complex similarity measure later on. In the MAC phase, we'd say, okay, the paint color should be equal to what the query says, and that boils down to a lot less cases that need to be run through the entire pipeline. For the FAC phase, we again use the attribute value helper because we are dealing with attribute value representation. And here we see that we again define it based on the attributes. For instance, here the model now again uses a nested version of this attribute value helper because as we saw in the query, this is now a nested representation, meaning we can use it again to define even object-oriented similarity functions. And then we can also say that for certain types, we want to have a default similarity measure. For instance, for strings, we could say that we use some embedding, and for integers, we use some linear similarity. So in case an attribute exists in the query that is not defined here, it just falls back to the type of the attribute. And then finally, we can also customize the aggregator. In our case, we use the arithmetic mean, but apply some custom pooling weights to customize it. And then you may have wondered, so we have here mild similarity. This does not come from CBRkit, and it is also not called here. So what does that mean? This means we have now used a custom similarity function where we again have the same signature, X and Y having the same type, in this case int, returning a float. We can use that directly in our code here without needing to call it because it does not contain an inner function. So if you want to define a custom similarity function, you don't need to be so involved and have a nested function defined that is then returned and called. Just define it once and then pass the name. Now we can build our retrievers. First, we build the Mac retriever, and we use the previously defined Mac similarity and say that at least we want 1.0, so exact matches here. And then for the fact retriever, we use the fact similarity and say that at most 10 cases should be retrieved. And then we apply both of these retrievers at the same time, so they are run sequentially, getting us the result we need. Okay, that is the quick demo of our CBRkit framework. And for more information, help, and stuff like that, please visit our GitHub site. The documentation is linked from there, and it contains even a small tutorial. Finally, I want to provide some insights based on a user study we conducted, where we compared the CBRkit to the Java-based ProCake framework also developed at Trier University. The experimental setup is given using virtual machines, where everything is identical between individual participants. 12 participants conducted this study, and we provided them with code templates to mitigate some of the differences between Java and Python. The participants then used a 5-point Likert scale and answered some free-form questions to provide feedback. And in total, there were 4 tasks to solve. So first, creating a query, assigning then similarity measures for the different attributes, constructing a retrieval pipeline, and for CBRkit only, implementing a custom similarity measure. Because we found that with ProCake, this is a much more complex endeavor that is not suitable for such a user study. First of all, a small overview of the self-assessment of skills. So we see here that many people are familiar with Java, but also Python. Some have no Python experience at all. And CBR experience is also mixed. Some have pretty good experience, some have no experience at all. So a rather mixed audience. When asked about the proposed development and deployment stages, the participants said that they see CBRkit mostly in the prototyping to small scale scenarios, so single user applications, for instance, whereas larger scale or even cloud-based approaches tend to be seen for or more fitting for ProCake. And the participants also noted that this is mostly due to ProCake being more mature and also being written in Java, which is considered to be a bit better for enterprise. Then going to the individual tasks, we see that defining query was possible for almost everyone in CBRkit. If you struggle with ProCake, it has more boilerplate code here. Then defining similarity measures, there were some problems in both frameworks, but a bit less in CBRkit. Defining the retrieval pipeline with MacFac, here we see that CBRkit made it possible for many participants to do it. Some struggled, but with ProCake, there was only one person that somehow made it, but the rest were unable to construct this pipeline. And then we also see that something which we treat as not being possible in a study in ProCake, which is defining a custom similarity measure, is totally possible in CBRkit. If we only consider the assessment of CBR experts, we get a bit different picture here. So we see that in both task 1 and task 2, so defining the query and the similarity measures, CBRkit comes out ahead. And even for CBR experts, it was hardly possible to do the MacFac retrieval in ProCake, whereas it mostly worked in CBRkit And again, the custom similarity function was also possible. Moving on to the assessment of Java developers, we see that the charts are almost the same. So if we switch back and forth, we see that there is little movement. So mostly the people that said they are proficient in CBR are also proficient in Java. More interesting is the assessment of Python developers. Here we see that they struggle a lot more with ProCake, where some were unable to set up the query and also the similarity measures a lot more. And no one was able to really fully do the MACFAC task. Okay, now to conclude. We show that it's possible to combine CBR and machine learning applications using a suitable framework. And CBRkit also allows the creation of custom CBR applications with limited knowledge in Python and CBR, making it easy for newcomers to join the CBR field. And everything we have shown here is open source, and we are actively looking for contributions. So in case you find a bug or want a feature, just open an issue or even better, pull request, and we can work towards that with the community. Obviously, there are some limitations. As I already mentioned, the framework is currently focused on the retrieval only, with adaptation and the other phases coming up next. And there is no real-world evaluation, meaning that we have only data based on our user study, but no a feeling of how it performs in the real world in projects involving more people and also being done over a period of many years. So that is something we want to have at some point. A future work for us is the investigation of hybrid AI. Now that we have a bridge between CBR and machine learning, how can we do hybrid applications where both approaches are combined? Then we want to add more abstractions, meaning more similarity functions, and as I said, also adaptation abstractions. And lastly, create a graphical user interface for novice users so that it gets even easier for newcomers to join the field. Okay, so that was the introductions to CBRkit, and I hope you are as excited as we are about this new framework. And as I said, if you have any issues or feature requests, just let us know via GitHub. So see you and thank you.